So yeah. So let's. I guess we'll get started. Shall I just share my screen and we'll just start from there, or do you want to be sharing on your screen first?
I think if you start sharing first, that should work best.
Okay. So
The other thing you want to do is just pull the latest from the Holochain Dev Camp generic game repo.
yep. So projects. I'll just make this a bit bigger. Generic game.
Yeah, and just check you've got the right origin.
How do you do that one?
I think it's just git origin. Nope. Sorry, remote. Like git remote.
Origin.
And then like -v or something.
Let's see. Well, let's git pull. Get the latest. It's already up to date. But yeah, I might be pointing to the wrong one. So maybe I should just download from your repository.
Yeah, I think I moved it into its own organization. So it should be there.
Cheers.
Yeah, we're trying not to clog up the main org.
I think I had this. Yeah, I think I got the old one. Yeah, this is different. All right.
And the other thing is, do you have Nix shell installed already?
I do, yeah.
Cool. Okay, so that's like a dependency of this.
And the Nix shell, if people want to install the Nix shell, they can go to the Holochain documentation.
Yeah, in the quick start, it should be right at the top, basically.
And
or probably developer.holochain.org.
Let's go there.
Yep, and on the quick start.
Install Rust, and then the Nix shell.
Yep.
Which would be that.
That's it, as easy as that.
And then install Holochain and DevTools.
So we'll have a different command for that, just because that holochain.love thing kind of follows the develop, but we've got this like pinned to a particular release.
Good. That's what we're hoping to discover on school. Yep.
Cool. So I've written up some instructions in the repo itself.
Okay.
And they're under demo moves.txt.
So now we've got generic game. And instructions, start the conductor straight away.
Right. Yeah, so I've written up some different instructions. I'll probably move these ones into the README once I'm happy with them.
Yep.
But yeah, we've got some other ones just to test out for the demo.
Okay, where are they?
There should be a file called demo moves or something like that.
Yep, demo moves.txt.
Right, so this is pretty much the things you could follow if you wanted to run a demo with 2 agents. And in this case, we've got them both running inside one conductor. Just, because it's a demo, we want to have as few moving parts as possible.
Yep, and so in that repo, if we have a look at that now, it didn't start up. Oh yeah, so we've got 2 agents in here.
Mm-hmm. And if you want to look at the conductor config as well, really quick.
Yep. Conductor config.
That's set up to load the DNA, which is already pre-built, so you don't need to build it again.
So if you go run HC package, it will generate.
It will, but I'd suggest not to do that and just to use like holochain-c with that config. Just because if something changes, then you'll end up with a different hashed version. And
oh, okay. So it's too risky. You might end up with a completely different hash version.
Right. So I just kind of pre-built it and put it. It's only 2 megabytes, so I just put it in the repo. So that's the compiled WASM.
That's it. So people who are starting should not change anything. They should just take this copy this repo as is.
Yep. So you won't have to build any WASM.
And it's because it's already pre-built. basically.
Yeah. And if you load up the Nix shell using that command,
Okay.
at the very top of that text thing,
So
that
we're
will
going
be
to load
the
up
black and white
Nix.
version it needs to run.
And this is the Holonix version here.
Yes, that's not the same as the actual holochain version. That's just the Holonix release.
But to find the holochain version, you have it in a file here, don't you?
It would be in zones and then in the cargo toml.
Zones and cargo.
So we're using 0.0.25 alpha 1.
So you've statically set this to use, where is it?
It should be that tag there, yep.
Holochain Rust. So that one there. So it's using version 25 alpha 1, okay. And that's for holochain and the dev tool?
That's for all the crates, mostly for
yeah. I guess all I was saying is that because we're only just using holochain for this, aren't we? Just the conductor.
Yeah, you got it, yeah. So you don't really need to worry about this. It's all there, but it shouldn't matter too much.
But say, for instance, they did have to change version. This is where they'd change it.
Yeah, that's right. And then you could use HC package to rebuild the dist or the .dna.json, and then you'd be good, hopefully.
But you'd probably have to update the DNA string as well.
You would, yes.
Because it might be slightly different.
Yep, you can just run a HC hash, and that will print out what the current DNA hash is.
So I go HC hash.
You might have an old version there.
All right. Anyway, so I'll start up. Well, actually, what shall I do? Shall I try and just quickly do that? Next shell holochain love HC hash just to find out.
Yeah, but I'd load up the particular Nixos, the particular Holonix thing we've got there.
Okay.
Just to be sure.
Go this one.
But currently that's the same one that's on holochain.love, but that may change.
Here we go.
It might take a little while as well.
I'm sitting on some pretty fast internet here.
Oh, okay. So am I, man. USA, they know how to do internet.
Whereabouts are you?
I'm not exactly sure. I think it's called Fresno.
Okay, wow.
It's okay. It's not great. Their internet's fast though.
Yeah. The best thing I loved about living in Bulgaria was the just fast internet. We just don't have it in Australia. But while it's doing that, should we talk through a bit more of what we're going to do next?
Yeah, let's do it. So all of these commands you can basically just run in order. So that one's going to be starting the conductor.
Yep.
And then we've got the CLI.
And then we run.
So I've said in their own terminal windows. So you want to start up kind of two separate CLIs, which will both connect as different agents.
Okay. As agent one, does it automatically connect as agent? Or you have to specify to connect as agent B, or
those instances that you're connecting through, it's specified. Like that instance one is agent A, for example.
Yep. No, that I just didn't see that there, and that directly correlates with something here. No.
Yeah. Okay. They're called 1 and 2 there, but they're called agent A and B in the other thing.
And that's sitting in the not here. Where's that config file? Oh, this one. There we go. Instance 1 and instance 2. Cool.
Yep.
All right, that's run. That's good. So we can start the conductor now.
Yeah, hopefully.
And let's cross our fingers.
Yeah, like this Nix shell thing is pretty great. Like, you shouldn't really have to worry about it working.
It feels like Dropbox a little bit, but I mean not Dropbox. What is it? Docker.
Yeah, right. Except it doesn't work on Windows.
Okay.
Which is something to keep in mind, actually. We do have a process for running Vagrant and then running Holonix inside that, which works pretty well.
Yep.
But yeah, there you go. So you're up and running 2 agents, which are currently networked, sort of. I mean, they're in semiconductor. And it should be, waiting for RPC calls on the right port.
And so here we've got what entries being written here.
Yep, so that's the regular startup process. So it'll write the DNA entry and the agent ID entry for both agents.
That one and that one.
Yeah, and that should be them holding the entries for each other as well.
Okay. Oh, yeah. So that's holding the entry, which is to that one. Maybe, I don't know.
Believe so, yeah.
Something like that. All right. Well, that's pretty cool. So it's 2 peers validating each other, basically, according to some validation rules for those.
Yeah. I mean, the validation rules for starting an agent, I think, in this are just basically anyone can join. But if there were actually validation as to who could join, that would be run when you start it up like that.
And it would spit out something else instead of validation okay here.
Yeah.
That's pretty cool. And then, yeah, okay, so there's a log or there's something there. Anyway.
You get a lot of debug output at the moment.
Yeah, okay. So now we should run these CLIs.
Yeah, so we need another window.
We'll do a black and white one over here. And we are running as agent 1.
Yeah, so this will depend on you having your own Rust install, but I'll assume that you do.
Well,
shell, and then you'll get Rust through that.
So shall I just to do it safely, should we just go through the next shell on every single one so then everyone's getting the same environment?
Yeah, not a bad idea. I might add that to the instructions actually.
So let's now we'll start up a next shell again so it can pull the right environment to start up this CLI.
And it should be faster this time.
Let's see that. It's very colorful, beautiful.
Yeah.
Do you get to choose the colors when you create that interface, or is it?
You can set it up in the config. I'm pretty sure you can kind of customize the debug quite a bit. So currently it's just set to like dump everything.
Are they holochain colors? They are.
Oh, maybe. I thought they were random, but you could be right.
Someone's chosen those colors, I think.
So it's not that much faster, is it? Looks like it's still downloading it.
So I'll start up another shell. Do a homebrew one. No. Ocean.
So I guess if you were demoing it live, you'd want to set all this up beforehand.
Yeah, so you'd have these different, these other 2 windows going separately.
Yeah. I wonder if I should pre-build the CLIs as well, maybe? That seems kind of risky though.
All right, I'm now setting up the other, starting up the other next shell in the second user terminal.
Yeah, we had a code run that one. So they'll install the dependencies, build it, and run it in one command.
So it's running 25. So now we just run this instance.
Yeah, so we didn't actually really need, like these don't really need holochain, they're just little Rust command line things.
Yeah. But using the instance would have made us have. Oh, they don't need holochain at all. Okay, so
Yeah, I mean, and you could connect from another device or whatever. They just use WebSocket. Oh, they use HTTP actually.
yeah.
There is a web UI in the pipeline, but I wasn't quite like happy enough with it for this demo. And I think it kind of distracts from what's really going on.
Yeah. Oh, yeah, so it's another whole layer putting all the web buttons on it, isn't it? So, but I mean, the CLI that you created is pretty cool for demonstrating.
Super cool.
Yeah.
So another thing we could look at while we're waiting for it to download all of those is in the repo. There's another file in the root.
Let's open that up.
Which is called, it's a .pdf, the generic game diagram. And that's just to give a little bit more kind of insight into what's going on when we're actually playing the games. So I'm not sure if you want to kind of use this in your demo, but it's kind of a resource.
So to explain this, so agent A sets up a game and publishes it to the DHT.
Yeah, you got it.
And says, I'm ready for another player to come along. And then agent B says, yep, it pulls that something that identifies that game instance, I guess, and says, yep, I'm keen. And then makes the first move and publishes the first move into that game.
Yeah. So as well, like, yeah, the important thing is like the agents are kind of actively pulling into their own hash chains and signing them again. So you'll see that when agent A authors the game, they sign it, but when agent B pulls it into their hash chain, they sign it again. So it ends up with two signatures. And
two signatures here. So agent B has pulled it down here and signed locally, and then it's signing locally its first move and then publishing that to there, and then agent A is now taking that and checking it against its own validation rules, which they should have the same validation rules, and then publishes it locally themselves, and then goes and makes move two. So that's the workflow.
Yeah, so for this particular pattern, both agents kind of end up with the same local chains, basically, which is kind of awesome, because it means then later you can validate actually based on the chain content. So you can't validate based on things which are in the DHT space. You can only validate based on things which are in local chains. And so by kind of following this workflow, you can be sure that you can always reduce the game state from either agent's chains, and that everything's countersigned.
So you basically have, with integrity, even just by looking at one agent's database, you can still check that everything's got integrity, that the rules were followed. Yeah. Even if you didn't have access to the DHT that the game was hosted on.
Right, and that's kind of why you do it. It's because when you're validating, you don't necessarily have access to all that data.
Because on Holochain, it can be just a direct peer-to-peer transaction.
Yeah, I'm not sure if that quite explains the reasoning behind it.
Yep. Okay.
But yeah, basically, to ensure the validation functions are deterministic, they need to only take a chain as input.
Yeah. Okay. All right.
So for example, if the network went down, you wouldn't be able to go and retrieve data, so you couldn't do that inside your validation. It has to be a pure function.
Oh, okay. All right. Yeah. So you can't retrieve data, but you can check if integrity is there. Basically, in this case. Yeah.
And it looks like we joined. So there we are in SCLI. So you can type help if you want to see all the different things you can do.
So we've got a little instruction set. We got our agent address, which that would have just been pulled out of our agent file, wouldn't it?
That's right, yeah.
And we can type help. And we've got some awesome moves here. Join a game. So that's what we're going to do. Oh no, we're going to go new game. Within a use that address. Okay. So we should start up the second agent.
Totally.
Go. Instance 2. Well, that was quick. Instant 2 was very quick.
Right, so it's already cached all of the crates, which is nice. Cool. Okay, so now we can start up a game, and you can kind of just follow this as a script, and it tells you if you should be making the commands as A or B.
Okay, so here, if I make command as A, I should be taking. What do we got here? Where's that other window? It is. So here we've got an address, and we want to first start a new game. We want to create a new game, and we want to put in new game, create new game with opponent usage, new game, opponent address. So we want to take the opponent's address. That's interesting. I would have thought we'd just publish out that we're creating our game.
You can do that as well, but I wanted to keep it as simple as possible for you.
All right, so we're going to directly talk connect to this.
Yep. You see that you can also create proposals, and that's when it is what you say. You kind of say that, like, I'm creating a game. Does anybody want to play with me? And then later people can accept your proposals, for example, and you kind of bootstrap a game that way.
Yeah.
But if you do have somebody's address, you can really just create a game with them directly.
All right. So it's basically because we're publishing to the same space. We're basically just bypassing the proposal workflow and going straight to joining into a game.
Right. It's like if we used a side channel to exchange our agent addresses.
Yep. Okay. All right. Well, let's do this. So new game. And we're pasting in this guy's address, which is actually this is the same anyway, isn't it?
Yeah, it is.
Cool. And so new game's been created, and non-creator must make the first move. All right, so this player B must make the first move. So they've got to join the game first.
Yeah, and so you join it based on the hash of the game now, which is what's currently on the prompt.
And that is the same hash here.
It should be. I hope it is.
It's not.
No, it's different. That's interesting.
So I wonder why that is, because everything is meant to be the same, isn't it?
I wonder why that is. I'll have a think about that. There'd be a really good reason why.
Yeah. Or maybe there's some, stopping of clashes and stuff somewhere along.
Oh, I remember why. I think they're timestamped.
So there we go. Collision.
Yeah, exactly for that reason. So you don't, if you want to play a game with somebody again later, they would collide if they weren't timestamped.
Yeah, so that's really important so that you know that who you're playing with. You don't randomly do the same thing with someone else across the world and then actually join into someone else's game.
Right, yeah, you've got to be thinking about hash collisions like all the time.
All right. Okay, so we'll take that hash and we'll join the game. Oh, and we've got some activity over here too.
Right, and so we could probably trace through this and figure out what's going on, but we should see at least one agent publishing the game to their local chain and then to the DHT. We should see gossip, and then we should see the other agent holding that in their DHT shard. So currently the sharding's set to like 1, so everyone's holding everything.
Yep. So that's interesting. So we can see the activities we did with instance 1 up here.
Mm-hmm.
I think. No, that's what's starting it up. I would have thought instance 1 would be here when we created the game, but definitely instance 2. We called a zone function here. Zone name is that signature. Anyway, we passed in this perimeter, which was that hash, I think, maybe.
Yes, that's the joining of the game.
All right, well, let's keep going.
Okay.
So now we've joined the game. So next thing is moves list. So B is going to move. So
yeah.
I have
So
to
you
run
don't,
moves first.
but you can just check what moves you can make.
All right, okay.
So you can either resign or you can move a piece, basically. So it doesn't tell you like all of the valid, checkers moves you could make, but it gives you the kind of shape of the moves that you should be making.
Oh, okay. So that is just giving you a template to put stuff
So the
in.
reason behind this is that this CLI works for any kind of game. Like it doesn't just work for checkers. So it also works for, I think there's tic-tac-toe in this repo, but during the dev camp, people made all different kinds of games and they could play all of them through this CLI without making any changes, which was pretty cool.
So yeah, and we've got an X and Y coordinate here. So there's a Y and X. So X is 0, Y is 0. So that would mean there. So that. This is probably my player view here, isn't it? No. So anyway, move that to. All right. So that's just a template. That's not making sense there.
It's just nothing.
Yeah.
But all the valid moves are in the text file.
Where's the text file?
Oh, like the demo moves.txt, the one behind the.
All right. Okay. So we'll make this move. So we're going to move from X1, Y5. Where is it? X1, Y5. So that one there to X2, Y4. So that to X2, Y4. So it's going to go up diagonal to there.
Right. So that should be a valid move.
Yep.
Under the rules of checkers.
Checkers. Yeah, this is checkers, isn't it? It's backgammon as well. Oh no, backgammon's different.
But yeah, there's a lot of different rules people play by as well. But if they want to play different rules, they've got to fork the DNA.
But in this context, we've created these rules, which we'll discover now, I guess. So I'll just go ahead and put this first move in. And it basically did a bunch of stuff.
Yeah, it's a pretty good way of putting it. Did a bunch of stuff, and now we've got the move.
And look at that. It's moved.
And if you open up the other agent's CLI and just hit enter, you should be able to get a refresh, and that will have synced with this guy as well.
Oh, there it is. It's moved. And in here, we've also got a bunch of validation that's happened. Somewhere. So if we have a look at the code, the validation code on that move.
Yeah, let's look at that. That's a good one.
So we're going to the zones because all validation sits inside a zone. And we're playing checkers. And I guess it's going to be under here.
Yeah, that's a good one.
So
let's check out the move is valid callback, which is what's being run during validation. And it should be pretty readable, I think. Basically, if you're moving a piece,
this is it here, isn't it?
Basically, that's like the top level. So if it's in bounds, and the from position's in bounds, if the piece belongs to you, if the place you're moving it to is empty, and if the rules of the game allow you to actually do that move, then you can do it.
And then send back OK.
So we can get in as well. I think the next example is making an invalid move. And you normally get pretty good feedback as to why that move was not valid.
Yeah, okay.
Which is pretty cool.
So these are the validation rules. So we passed in basically that XY coordinate, which was there. Where are we passing that object into here?
So that comes in, so it's implemented on move, so it comes in as self, if that makes sense.
It comes in here, does it?
Yep. So it's just a function on move. And you see there we split it out into a move piece because move type is an enum. And that's where you can access the to and from positions.
All right, and then this is, okay, the from and the to, and then it checks, then it goes and now checks is in bounds, which is probably not, where's that defined?
That might be implemented on move, but you can scroll down and see some of the other ones. So like is player's turn is a good one, which uses the current game state and the list of moves to figure out like who the last player to make a move was. And
you pass in the game and the game state. All right.
And so all of this stuff, is specific to the game of checkers. And so if you wanted to do different rules here, you could probably kind of mix and match them, which is what a lot of people did in the dev camp. And you can actually build a lot of games out of basically the same rules. It's kind of funny.
Wow, okay. So it's just a few, so to get good at playing game or creating games on Holochain is really just a few mechanisms that you need to understand. And then you can...
Like if you think about Connect 4 or Tic-Tac-Toe or Reversi or Dots and Boxes, these are all some of the ones people made. They follow very similar rules. It's like players take turns, they kind of make some move. Normally it's like there's pretty simple rules as to what move you can or can't take based on the state. So this kind of repo is set up to help you write those. And basically all you have to write is the validation.
Yep. And that's pretty cool example of a smart contract, really, or the equivalent of a smart contract, I guess.
Yeah, the equivalent. It's nice as well when it's kind of just between two agents. I think this is where this Holochain pattern really shines.
It's very cool. So I've just gone and put in the same move again, and this will probably show it not as a valid move. Should we test that out? Or you want to continue with the...
No, definitely test it out. It's more interesting to see invalid moves than valid ones almost.
Okay, so now... Whoa!
So first up, you can see we get pretty nice output. Validation failed, it's not this player's turn.
Oh yeah, okay, so that was the first check, and then it would have checked if it was my turn. So it checked the game state first, and then it would have checked whose turn it was, and obviously I didn't match up as the right person, and so it caused an error.
Right, and so the validation failed actually on this agent's node. The other agent wasn't even involved in doing this. This was like the first line of checking.
So that's pretty cool. So it doesn't even send a signal. It didn't even send a signal out off this computer.
Yeah, that's right.
Off that instance.
So it didn't mutate our local chain, and it didn't try and send anything to the DHT, which is pretty cool. So only valid things can enter the shared space.
Yeah, that's very cool. So it's just an example of how lightweight Holochain is, but still very powerful.
Right, and you could picture a scenario where, this agent had somehow hacked their runtime such that it ignored these validation things. And then, so this agent would then be cryptographically signing something that is fails validation. And if they then kind of gossip that to the rest of the network, the rest of the network will run it against true validation and pretty quickly find out that they had signed something which was incorrect.
Yeah.
Which can never happen by accident. This can only happen by malicious purposes. All
right, so we should now go over to player A. So player B made the first move. Show B can't move now because it's not a turn. So we just tried to make another. That was an invalid move as well, isn't it? So let's now move A. So player A is going to now make a move. We'll go into the player A's keyboard or terminal. And what are we doing here? So we're moving player A X 4 Y2, X 4 Y2, which is that one there, to X3, which is on this one, Y3, which is there. So we're going to move straight up to there. Okay. Waiting for gossip. So that's basically publishing to the THT and waiting for some sort of return.
Yeah, actually, since I just use HTTP rather than WebSocket, it's literally just waiting for what might be long enough.
Yeah. Okay.
But if you're using WebSocket, you can actually get feedback back as to how things are going, which is pretty cool.
And now we can see our latest move there. What was the command to just see the state again? I just press enter, don't you? So now it should upload here. All right, we're really playing each other. So make an invalid move as B, show validation.
So this is a different kind of invalid move. So we're testing a different part of the validation, if you like.
So player A is again trying to. Oh, hang on. Let's just make a move as player B. All right. So we'll.
It's invalid either way.
So we're going to play it here, and what we were moving X to Y4, X to Y4. So there's no piece there basically. Oh, sorry. No, there is. To X3, Y3. X3, Y3. Okay, so we're trying to actually let's move straight onto that, and obviously in Game of Checkers that's not correct because we should be moving up to there.
Yeah, look, this person thinks they're playing chess.
Yeah, okay. So we'll go ahead and do that. And again, so it's now caused a different type of validation move. Yep. That's pretty much it, isn't it? Make the correct move.
And so this is the same move, but actually hopping over that piece rather than onto it.
So now we're going to instruct it to move over there and take that checker away. Beautiful.
And yeah, that's about it for the demo. I mean, you could play the game out, but it doesn't yet have a win condition. So you could play it until all the opponent's pieces are gone, but it won't end automatically.
Yeah. Okay. So you basically just come to a standstill where you can't move anymore.
Yeah. It also doesn't have the when you get to the other side, you're supposed to become a king, and then you can move backwards. It doesn't have that functionality either.
Yeah.
Yeah.
Very cool. All right. Well, I think thanks very much for that. Is there any sort of final words that we need to say, overarching, about anything that we've done that would help people?
Just maybe tying it back to the diagram might be worth it.
Yeah. Okay.
And just thinking about what we're really doing here, which is kind of managing a state between two agents, which has really strict rules as to how the state can be mutated, and doing so in such a way that maintains the integrity of that state over time. Yeah, which is pretty awesome. I mean, that solves a lot of the problems that distributed systems need to be able to solve.
And if we could just go back over here, so you've actually got another game in here. So this is all the. So the way you've sort of set this out, you got the checkers game, you got tic-tac-toe game. What's mod? Okay, yep. moves. So most this is just the moves, okay. Most of it's sitting in the validation, basically.
Right, and that's an important thing to note on, is that really, yeah, the validation should be the majority of your code in a holochain zone, because that's really what's doing the data integrity.
And so let's look at this zone. Where does this zone start? Because they're all helper functions.
Right. Oh, so you could probably look in the lib.rs.
All right. So this
entry point. So if you can switch it over to use tic-tac-toe instead of checkers. But yeah, that hash zone decorator or attribute, I think it's called in Rust, is saying that this module defines our zone, and there are a few callbacks. So there's the init callback, which is call on startup, and the validate agent, which is how you allow people to join the network, and this is just saying that anybody can join. And then these are all the callbacks, all the zone functions, which are how we are kind of interacting with the state. Oh no, sorry, they're the entry definitions. So the entries are, there's games and there's game moves, which are the only two things we used, and the other two things are proposals and anchors, which are used for actually finding other people to play with, which we didn't touch on.
And there's that create game function that we used. We passed in the agent address, or the opponent address, didn't we?
Yeah, and you'll notice that all of these are pretty light compared to the validation. So they're really just wrapping a few extra kind of pieces of functionality, like a few extra steps, and making them, easier to call. You should still be able to maintain data integrity without going through these functions. So you could think of these like helpers.
Yeah, okay. And it's interesting that you've in holochain, they separate the validation away from the methods of the functions. It's which is interesting. So when you're defining the entry, so game entry, where's that?
That would be in, I think it's in game.rs actually. Might be down a bit further. Maybe not. Where is that? Oh, there it is. Yep.
Yeah.
So that entry macro is how you define entries, and you have to register them in the zone. But yeah, so this is how we're defining its name, some other properties about it, like if it's shared publicly, what goes into the validation function. So again, you only need the entry itself, but if you look at the moves, that will actually be the full chain of the authoring agent.
Yeah.
And the validation for this is pretty light. It's just that you can't play a game with yourself, and that's about it.
And that's the validation for it, though. Yeah.
But if you look in gamemove.rs instead, for example, and scroll down to the definition here, so you can see that the validation package takes the full chain. Oh, sorry. Oh, okay. Sorry. But yeah, you can see the validation callback. It's a bit more interesting.
Yeah. All right. Well, I think we'll leave it there. I think that's really good. Thank you very much for that. And I guess one more question is, if people want to start up the tic-tac-toe game, is it possible for them to do that?
Yeah, if you just comment it out in the lib.rs, if you comment out checkers and comment in tic-tac-toe and rebuild it using HC package, you can play the other one. That's the only change you need to make.
So this is here. This is where you'd import. No. Comment out this and comment in this.
Yeah. So So it's not the best practice, but
it's a really cool button. All right, that's perfect. I'll end it there.
Cool.
So guys, yeah, go out and share this game and share the validation of Holochain.